Well, the focus that I'm working on with support from the National Energy Technology Lab and in collaboration with our Energy Institute at Pitt are focused on CO2 sequestration. Really, the idea is to utilize these underground structures, which we can image and understand and map using geophysics, to store CO2 to isolate it from the Earth environment. The principal goals are to develop an understanding of how we can best image hydrogeophysics and energy systems, specifically pore filling phases that include hydrocarbons such as natural gas and oil. We're trying to make very accurate reconstructions of the interior of the Earth, and we either use electromagnetism, which your cell phone uses, or we use elastic waves, the types of things if you stretch a rubber band and snap it, the kind of motion that goes through that rubber band. Here at the University of Pittsburgh, we have a very strong combination of both centers and faculty who are world-renowned, and together they're much larger than the sum of just the individual pieces. So three centers include the Center for Energy, the Center for Simulation and Modeling, and the Pittsburgh Supercomputing Center. In addition, we have world-renowned faculty such as Dr. Bob Enoch, who's specialized his entire career just on the chemical properties of supercritical CO2 with respect to enhanced oil recovery. Or faculty such as Dr. Ken Jordan, who's focused on the quantum chemistry of gas hydrates, a very important energy resource for the future. If I'm trying to measure a sample of an electromagnetic signal which is 1 part per million, so what that means exactly is if we send out 1 million parts of this signal, I hear back 1 part of the million that we transmitted. But unfortunately, your cell phone also, when you talk on it or it's communicating with the cell phone network, it's broadcasting out electromagnetic waves also. And we have to somehow sort that out and eliminate it and interpret that 1 part in a million signal. What we're trying to understand is the geometry of the structure, the response of the supercritical CO2 in the underground structure, and the safety of that structure with respect to it safely containing and isolating the CO2 from the Earth environment. What we're hoping to find is a fingerprint for CO2 in the subsurface, that is an actual distinctive attribute or parameter that anyone can record and understand that supercritical CO2 is in the geological environment. The tools which we use, I'm happy to say, are really state-of-the-art tools. So we've received software donations, for example, from Schlumberger in excess of $5 million just for software tools. Landmark Geophysics, which is a large company based in Houston, Texas, we probably have $15 million worth of tools. Sun Microsystems also donated four processor terabyte systems for our research. Outside of the defense industry, the most intensive use of computer systems is in geophysics. Energy companies have the largest non-defense computer labs in the world, and so we also have a small subset of some of that expertise with respect to hardware and software. Here at the University of Pittsburgh, we have experts in the natural sciences and engineering, and their expertise is very valuable, for both our country and the world. So we're really training people who are going to solve these difficult problems, both in energy and water resources. In addition, in these projects, we have very strong collaboration with the National Energy Technology Lab at the U.S. Department of Energy, both in Morgantown and in Pittsburgh. The specific labs that we're working with there include experts in electromagnetic geophysics, computer tomography, and rock physics, in addition to engineering, materials engineering. The training of students in hindsight is really one of the very most rewarding things that I do. And I know in this program, I've been here at Pitt for about 20 years now, and when you see the careers and the difference that these young people are making, it's just incredible. So I think that probably one of the most important jobs for a research university like the University of Pittsburgh is really allowing students to really, the sky's the limit. They can really put their dreams and ambitions on the stars and follow them to the stars. So when they come out of here, they're highly, highly regarded. My aspiration is that this problem is solved so that we give society and the world verifiable and repeatable tools where they can be used globally to map precisely the location of stored CO2, And potentially a dream would be to both solve the climate issue and the energy issue with one technology.